Hello, welcome and a very good evening. And tonight we have this beast here, which is the Atari ST in a slightly disassembled form. And we will have a closer look in a second on the table, on the bench. But you perhaps already saw this particular machine, earlier in a live stream. I added a bunch of sockets to add 512K of RAM, because this is a 520 ST-FM. The F means it has the internal floppy drive, which is currently not connected, the internal power supply, and the M means it has the TV modulator built in, and it came with 512K of memory. However, for what we are doing right now with this magic board here, we need 1 megabyte of RAM. So this whole machine belongs to Stefan, friend of the channel. He sent it around because his soldering skills are not that great and asked if I could install these things. And since I don't have an ST or plan to buy one, I said, okay, sure, if I can make a video out of this, I'm glad to be of service. So we put all these things in, and it actually works. And we'll have a look around the whole Atari ST architecture and what this magic board does. So let's take it over to the bench. Alright, so this is what the Atari ST 520 FM looks like, which has been upgraded to the 1040 FM basically by adding the extra row of RAM. Here is a quick overview of the main board from the Atari Museum. And basically, I'm putting this away, what we have here is below the power supply, which you can't see here, there are 6 ROM chips containing the TOS operating system. Here under this metal shield is the shifter graphics chip, which is custom made for Atari or something like that. We have the RAM, obviously. We have the memory management unit, we have the glue chip, which probably is something like the PLA or the ULA in the C64 or the Spectrum, something like that. I would imagine that this consolidates all kinds of logic chips, some glue logic chips, basically. Under this board, which I won't remove now because this is like a little bit of a precarious stack here, is the Motorola 68000, which is a pretty long and wide CPU. It's the exact same one as in the Amiga 500 and the Amiga 1000. So nothing new here, basically. And you have some additional things like the DMA controller over here. I think this is the DMA controller. This is the floppy controller next to the floppy drive cable, makes sense. Then there's a Yamaha sound chip. This one here, I'm not quite sure. This should be something with the I/O, I think. And this one here probably is also something to do with I/O, because at the back we have the hard disk, printer and modem ports, as well as the external floppy port. But this is all of not that much interest, because the card that we have here is something rather special that I didn't know existed. The Motorola 68000 was a pretty popular CPU back in the 1980s, stemming from the late 1970s even, I think. It was actually pretty powerful for its day. It was a hybrid 16 32-bit CPU with an external 16-bit data bus. I'm not sure what the size of the address bus is, but I think it was 24 bits, so 16 megabytes-ish, similar to the 286, but not 100% sure on that. Some other people probably can tell it in more detail, but roughly equivalent to that. And it even had some internal 32-bit registers. So it was not quite a 32-bit CPU, but had some aspects of it. So it was pretty powerful, and by the mid-1980s it was cheap enough that Commodore used it in the Amiga and Atari used it in the Atari ST, because, as we all know, Jack Tramiel left Commodore right around the time they came out with the Amiga, and he said we need to have something to put up against the Amiga, and they came up with the ST, this beast here, which is basically an Amiga Lite without all the fancy extra chips that the Amiga has, like the Agnes, the Denise, etc., and the Paula, but more simple things, I would say, but some other features that are pretty cool. Okay, the other competitor was, of course, the Intel 8086, or the 8088, used in the IBM PC and the XT, and its successors, the 286 and so on. The 68000 and the 8086 were totally incompatible. They used different byte orderings and different instruction sets, and more or less totally incompatible. However, by 1985, or even the late 1980s, it was totally clear that the IBM PC and the thousands of clones that came out were dominating the market. Atari with its ST line, Amiga, Commodore with the Amiga line, etc. They had a market share, but still it was all dominated, especially in the offices, by the PC. And when people were using their Ataris at home or Amigas at home, they wanted and needed some kind of compatibility to exchange data, to run programs, etc. The Atari ST already, when it came out, said, screw it, our floppy disk format will just be the one that MS-DOS is using. So on any given Atari ST, you can just pop in a MS-DOS floppy disk with the right formatting, of course, on the single-sided drives 360K, on the double-sided 720K, and it would happily read and write to them. It was the native format. So the Atari ST is using FAT on floppy disks. Very unsimilar to the Amiga, which had its own disk format and file system. So there was already some level of compatibility. However, running MS-DOS programs was much harder. Emulating an 8086 or 8088 on a 68000 was possible, but it would be very slow. As I said, different byte orderings for 16-bit values, etc. meant that there was the need of a lot of swapping. The multiply and divide probably had to be emulated due to the effect, and some other stuff. Everything very weird, and there's a lot of chips, like the DMA controller, the video card, etc. that you have to emulate. So just emulating the CPU was very, very expensive, and all the other hardware around that in the PC system was expensive as well. So what did some clever company called Sack, actually the name is, does it say here? Not quite. Sack Electronic GmbH from Germany, actually. They came out in the late 1980s and maybe around 1990, I'm not quite sure. But it seems to be from the late 80s, with this card called the PC Speed version 1.2. And they thought just putting some form of IBM PC into the Atari ST would be pretty expensive, although it would make for a very fast emulation or virtualization. But we can cut it down to the most expensive part of the emulation, the CPU. Because most of the time, a program would just simply run code, business code on the CPU, do stuff, and only when there's I/O happening to the graphics card, to the disk, doing BIOS calls, there was the actual need of proper emulation. So what did they do? They simply stuck an 8086 compatible CPU on a board with a little bit of glue logic and attached that on top of the Motorola. And that's pretty ingenious, because this board could be made for pretty cheap. It also uses not an Intel CPU, but the NEC V30, which is 8086 compatible. It has the 16-bit wide address bus, so it was pretty fast. It also executed instructions much faster than the original Intel CPU. So everything was actually pretty nice. The only thing that you had to emulate in software was mainly the BIOS for disk I/O, etc., keyboard, and also the graphics card. This software that belongs to the PC Speed can emulate CGA card, the color graphics card basically, or the Hercules graphics, monochrome graphics card, also the Olivetti standard, which I think was also monochrome, and something called Hercules Plus or something, which covered basically the graphics options before 1985. It can't do EGA, it can't do VGA, mainly due to the fact that the shifter that's inside here is actually not that great a graphics chip. It can do 16 colors at most. It can do the CGA colors pretty well, but it can do that only at low res, like 320 by 200. It probably could do the low-res EGA modes if they had emulated that, but it doesn't. So we are stuck with CGA graphics either in 4 colors or monochrome. Monochrome would actually be pretty fitting because a lot of the Atari STs would be delivered with high-resolution monochrome monitors because they were used, for example, for desktop publishing systems or for musical scoring where you rather need high resolution but not so much color. So you could just set it to emulate CGA high-res in monochrome or Hercules graphics. Although in Hercules graphics, the Hercules card has something like 700 and something pixels horizontal resolution, whereas the shifter can only do 640. So you won't see the whole screen at one particular time, but you have had some keyboard combos with a numpad that you could scroll around a virtual window. But that's more or less almost enough to talk about that. We will have a quick look at the software. But before that, it's very interesting how this actually works. I didn't quite look up what this thing does, but my guess would be the Motorola 68000 processor actually has a halt pin, which stops its execution. And my guess would be that whenever the emulation software runs and it says, okay, I'm done, everything is set up, the hardware and the memory contents are just like the PC part needs it, it would trigger something on these chips here to set the halt pin of the Motorola, which then would go idle and would not execute anything, and which would trigger the NEC CPU to continue execution wherever it stopped. And the Intel CPU has something very similar. It's called the test pin, and the test pin can be set high or low while the CPU is executing a wait opcode. So you can't just halt the machine as it is, but you would have to, basically write the BIOS for the system. Every time you jump into the BIOS or something, you would execute the wait instruction. I'm not sure this covers all the details that would be necessary. I imagine there's direct hardware access where you would need to force to halt the CPU. Maybe the NEC V30 has a feature like that. But I think the Motorola is definitely easier to halt and resume. This is, I think, quite ingenious. So basically only one processor would run. Therefore, you also don't have a problem accessing the memory and getting some corruptions. But as long as the DOS emulation is running, you can't access TOS at all. Basically, the Motorola just emulates the PC hardware and the BIOS calls. And the NEC, or maybe not even the BIOS calls. Maybe the BIOS calls are even 8086, I'm not sure. But something like that. It would just execute certain amounts of code that emulates the hardware for the PC part. And the PC would just run the user programs and do some kind of interceptions when I/O access happens or something. There's some glue logic here that probably helps with that. But haven't reverse engineered it. I probably can't do that. That's probably for some other people. Although I think it would probably be relatively easy to reverse engineer because there's not much to this thing. The only other interesting part is that this is actually soldered on top of the Motorola CPU. There are 2 sockets, so I can plug it off, but there is 1 socket soldered on top of the Motorola CPU. But I don't want to take it off because it's very nicely stuck on there now. I don't want to break it before I ship it back. So let's head over to the Mac and capture some footage on how this actually looks in real life. PC Speed comes with a bunch of programs. Most important of all is the install program, but there's also a mouse driver for mouse support under MS-DOS. And I also formatted this disk to be an MS-DOS boot disk because you will need that as well if you don't have a hard disk. So I put everything on one disk. The install program lets you choose between different things for the disk. For the keyboard, for example, to choose the German keyboard layout I needed. The video emulation, you can do Hercules, CJ, Olivetti, or the Hyper HGC, which I don't really know what it is. But the most important ones would be CGA and Hercules, and also, well, options for the different graphics and text modes, and there you can map different colors to the Atari colors, so you can have a slightly different emulation of the graphics hardware, for example. And yeah, if you quit the program, it will save its settings. This here is version 1.5 of PC Speed, and let's save this and run the actual emulation. Running the PC Speed program is actually pretty straightforward. You just double click on the program and it will start to boot. And once it's ready, it will prompt you to insert a DOS boot disk if you, for example, don't happen to have a hard disk. So you just press return and DOS is booting here. Incidentally, this is MS-DOS 6.22, which I simply created a DOS boot disk on my 486. And as we don't have an RTC clock, you will have to enter the date and time every time you boot the emulation up. And it obviously works in exactly the same manner as you would expect. You can use all the general DOS commands. The most important thing is that we're using black on white text. It could be that in the install program you can invert that. I didn't find anything right away. However, I didn't look very far, to be honest. And this mode here, while it may look good on a monochrome Atari monitor, actually has some drawbacks because the actual colors on MS-DOS would be inverted. And this is mostly a problem in games, as you will see later. But here we are running Turbo Pascal 3 because I thought this is so small that it can actually run from one floppy disk. It's a very old Pascal compiler by Borland, and it fits on one double density 5¼ inch disk, so I could cram it onto this special PC Speed disk as well. So let's run it and test out some little programs. Compilation is actually pretty fast, and on a real IBM PC or even XT, this would have been slower. The CPU is pretty fast for what it is. The graphics output, I'm not so sure how fast the emulation is or how far it goes. The 4-color CGA mode gets mapped to this weird black and white mode, as you can see, where the colors get kind of dithering. It's similar to what a Hercules graphics card would do in CGA emulation mode. It does the job, and I think if you had a color monitor, it would look more, well, CGA-like, of course. However, I only have this VGA adapter thing, and I'm capturing through the open source scan converter, the OSSC, which works reasonably well, but is only monochrome. One of the main arguments for owning a PC Speed would be to be able to run business software. And while I don't have an old version of Lotus 123 or something, let's use Microcalc, which was an example application shipped with Turbo Pascal 3, which is kind of like a Lotus 123 spreadsheet program. Maybe it's a bit simplistic, but something like that would definitely work. So people wanting to do some home office business stuff on their Atari ST that they already had and be compatible with other people using IBM machines, this would definitely be an option to do that. And it would be definitely much cheaper than buying a separate PC, which probably would also need a different monitor, and the whole PC system could easily cost you a couple of $1,000 or marks back in the 1980s. Although at the time, 1990 or something, I think this particular machine here, the PC Speed, would already have been pretty outdated because the PC came out in 1981, and by 1990 people were already switching at least to 286s, more often 386s, and perhaps the high-end people would use 486s. So this would be a very slow emulator even for the time being. Back in 1985, this definitely would have been something very cool though. But what about games, you might want to ask? And fair enough, I had one game that would fit on one double density disk for that matter, and that is Maniac Mansion. There are probably others out there, but I knew that this would definitely run on an XT class machine. And here you are, Maniac Mansion in all its CGI glory. The colors again map to some weird stripy dither pattern. On a color output, this would definitely look a little bit better. And indeed, it runs flawlessly, albeit with some weirdness in the music, as you will hear shortly. And I think it's probably not the best idea to run this game on this kind of emulator. So, gaming would probably not be the best selling point for this, and here you can see what the Hercules emulation would look like, and as you can see it wouldn't fit on the screen, you would have to scroll. However, gaming shouldn't be the selling point of this, as the Atari ST had its fair share of pretty decent ports and probably also exclusives, and you could play Maniac Mansion just fine on the Atari ST itself with much better graphics than the CGA version. So there you have it. I think this is more suited to business software and being compatible with the IBM PC world than to do gaming on the Atari ST, which it was more or less better equipped than, for example, a stock XT was. So that's it for the PC Speed, the Atari MS-DOS PC emulator thingy. It would be interesting to try this out a little bit more, especially with a hard disk. I, for example, would like to see how Windows 3.0 or 2.11 runs on this machine. Of course, it doesn't have a lot of RAM to its use, basically. It's only 700 kilobytes, but you could perhaps run a stripped down Windows 2 or Windows 3 installation, which could run on the 8086 with an old version of Word or Excel, for example, which could be fun, especially in Hercules graphics mode, where you have enough pixels to be of some kind of use. I don't think that you can emulate EMS memory. For example, on the Atari Mega ST, you would have like 4 megabytes of RAM, which would be plenty. And with a little bit of software changes in the PC Speed code, basically, you could perhaps emulate EMS as well. And then you would have much more memory for real mode Windows programs. And that could be pretty cool, but I don't think it's possible. There was, I think, a successor called 80 Speed, which had a 286 processor plus some proprietary hardware emulating all the stuff around the 286, which also has been reverse engineered, and there's a homebrew version of that, even though I'm not sure that you can buy it or how far advanced it is. But this particular piece here is already interesting enough, I think, and it would be interesting to see how far can you push it. What kind of applications can you run on it usefully? And I think by the time it came out, it was already like a niche product, because people who had an Atari ST were probably not that much into the IBM PC world anyway, because they were playing games or doing music stuff. But maybe there were some things that you could run on this to make your life easier, to exchange data. It definitely wasn't meant to play games, and by 1990 it was already, like I said, almost 10 years behind current PC technology. So its use was definitely limited, and the AT speed was perhaps more interesting because it had the faster processor. I'm not sure if they supported protected mode, for example, to run actual Windows 3.0 or 3.1 applications, which would have been magnificent. And also if it supported more than the 1 megabyte of RAM that the 8086 could use, basically, without stuff like the EMS standard. I don't know about that, but it's definitely pretty interesting. The Atari ST architecture is, I think, pretty ingenious because it's very simple and clean, because it had to be low cost. yeah, I would love to know a bit more about that stuff. Did you work with this thing back in the day? Or maybe with the AT speed or something like that? Leave a comment. Otherwise, share, like, and subscribe as usual. All your support is greatly appreciated, especially sharing on social media like Mastodon, God forbid Twitter or something like that. To spread the word, have a look at the other videos. And I hope to see you soon in the next year, in 2023. That's it for this year. Have a very nice evening and goodbye.